So this is the lesson for 5-1 scatter plots, all right? A scatter plot is a different type of graph that you're going to see where you don't connect the dots, all right? In a scatter plot, we don't connect the dots. Now, there are two very, very important vocabulary words right here. A scatter plot can help you determine if there is an association or correlation between pairs of data. All right, so you're going to be given some data, and tomorrow you're actually going to be making the scatter plots. Today you're just looking at them and answering some questions about them. So these are all scatter plots down below. The words association or correlation, all that means is the word relationship. All right, so what you're going to be asked today is when you take a look at a scatter plot, does it have a positive relationship, association, correlation? Does it have a negative association or correlation? Does it have no association or correlation? Or is it non-linear? All right. So those are your four choices: positive, negative, no, or non-linear. Positive correlation. The data, now I'm not connecting the dots when I go to draw this arrow, all right? But in a positive correlation, the data goes up. Remember that when you take a look at a graph, you always read the graph going from left to right, just like you read a sentence. So when you're looking at this data, you're looking at the general trend of the data. So as we go from left to right, just like we read a sentence, this data is going up. All right, that data is going up. As the one is increasing, the other is increasing. So as we go from left to right, the data is going up. In a negative correlation or negative association, the data goes down. All right, as we go from left to right, the data is going down. So as the X value goes up, your Y value goes down. So positive goes up, negative goes down. No correlation. In no correlation, there is no relationship. The dots are just randomly scattered all over the place. You can't tell in no correlation, you can't tell if these dots are going up or if they're going down or what they're doing. It's just a random pattern all over the place. All right. You can't tell what they're doing. Non-linear. Non-linear goes up and down. Non-linear, just like in the last chapter, is a U-shaped graph. Now, this U shape goes up. If we follow the dots, this goes up and then goes down. But it could also go down first and then up. All right. So it could go up and then down or down and then up. But non-linear is a U-shaped graph that goes both up and down. So again, positive goes up, negative goes down. No is random all over the place. You can't tell what it's doing. And then non-linear is up and then down or down and then up. On your homework today, on your quiz, you will be given scatter plots. You have to say, is it positive, negative, no, or non-linear? Take a look at the next two vocabulary words. These are two vocabulary words that you have not heard of before either: an outlier and a cluster. So an outlier. An outlier is very similar to like an outcast from society. Think about an outcast of society. An outcast of society is somebody who doesn't really fit in. They sort of stay by themselves, all right? And they keep themselves, they're different from everybody else, all right? So an outlier is a lot like an outcast of society. It is a data point that is far away from all of the others. So take a look at this scatter plot. In this scatter plot, first of all, is this positive, negative, no, or nonlinear? Well, this would be positive because the general trend of the data is going up. But when you take a look at this data, most of our data is right in here. All right. Most of our data is right in there. But then all of a sudden you have a random point that is far away from all the other ones. That point is an outlier. All right. That point is an outlier. It's far away from all the other ones. The other ones all form a nice sort of fat line right there in the green. But then you have this one random point. That point, that one random point is the outlier. Now, does the outlier always have to be above? No. If you had a random point down here, that would also be an outlier. A cluster. A cluster is a group of points that are very, very close together. It's not just 2 points, all right? 2 points don't make a cluster. It's like 3 or 4 or 5 or 6 points that are really, really, really close together. So these points right here form a cluster. They're points that are really tightly packed together. When you take a look at these other ones, they're more spread apart. So an outlier is a point that's far away. A cluster is a group of points that are really, really close together. So what the heck are your questions going to look like? Well, here's what they are. All right. So this first scatter plot that we're looking at looks at the hours spent studying and test scores. So first of all, what is the association? Is it positive? Does it go up? Is it negative? Does it go down? Is it no? Are the dots just randomly all over the place? Or is it nonlinear? Is it in a U shape where it goes up and down? Well, the general trend of this data is that as we go from left to right, it is going up. Since it is going up, this is positive. Again, on your homework today, you'll have questions just like this. Is there an outlier? I'm looking for a yes or a no answer. Is there an outlier? Well, looking at the scatter plot, all of a sudden you have this random dot down here in the red. Notice how all these other ones pretty much fit into that sort of straight line mode, but then there's one random one down here. This one random one is an outlier. So does it have an outlier? Yes, it does. Is there a cluster of points? Is there a group of points that are really, really, really close together? On this one, I'm going to say no. All right. If you take a look at your scatter plot, the dots are pretty much all equally spaced out. What we're looking for in a cluster, we're looking for dots that are really, 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 really close together, almost like right on top of each other. All right. Estimate a test score with 12 hours of studying. Now, if you take a look, hours of studying is along the bottom. If we go over to 12 and then go up from 12, where do you think on 12 that the next dot would be? All right, if that next dot is a 12, where do you think that test score would be? I think it would be somewhere right in here. All right, it would be somewhere right in there. Now, when they ask you to do an estimate, there's not just one correct answer. There's a variety of correct answers. Would a 100 be a correct answer? Sure. Would a 99 be a correct answer? Sure. Would 98 be a correct answer? Sure. Would 97 be a correct answer? Sure. I think we're starting to get away from the best answer. Would 96 be a correct answer? Yeah, that'd be fine. Would 95? Yeah. I think anything in between 95 and 100 would be a good, acceptable answer. Would an answer like 60 be a good answer? No. All right. When you take a look at the general trend of the data, it's going up. It's going to form somewhere in here. So would a point down here be a good answer? No. All right. We're just looking for a reasonable answer. Oh, by the way, if you're ever asked for an estimate, don't put down weird answers. Don't put down like, oh, I'm going to put down 99.125. Don't put weird answers. All right, just normal answers. Take a look at this next one. In this next one, we are taking a look at the average speed, and we're taking a look at the time traveled in hours. So the association, is this positive, negative, no, or nonlinear? Well, when you take a look at this one, we're looking for the general trend of the data. Now, notice that our data is only going down. Since our data is only going down, this would be negative. Now, you might have been thinking, oh, well, it looks like it's curved, so it might be nonlinear. Nonlinear goes both up and down. This is only going down. All right, it's only going down. Therefore, it is negative. It's not going back up. So therefore, it's not U-shaped. It's not nonlinear. Is there an outlier? Is there a point that's far away from all the others? No, there's not. An outlier here, if there was like a point up here, that would be an outlier. Is there a cluster of points? Is there a group of points that are really, really close together? Yes, there is. All right. If you take a look right here in the red, there's like 7 dots there that are really, really, really close together. All right. So that would be a cluster. Make an estimate of travel time with 80 as an average speed. So on my graph, I'm going to go over to where 80 is and then go up from there. Well, what would be a good answer for 80? I think anything right in here would be a good answer. So what are my numbers there? I'd say anything like 3. I think 3 would be a great answer. I think 2 would be a fine answer. 2.5 would be a fine answer. I think anything like that. 2, 2.5, 3. Could you make an argument for 1 or 4? Yeah, you could probably make an argument for 1 or 4, but I think 2 or 3 would be the best answer. Take a look at the next one. In the next one, we're looking at apartment rents from near a train station. All right. So somebody just asked the question, do we have to draw the line on the graph? No, you don't. All right. That's actually a lesson that's later on in this chapter. Nope, you don't. I'm just showing you the direction that it's going in. So what is the association of the graph? Is it positive, negative, no, or nonlinear? What is the general trend of the data as we go from left to right? Well, as we go from left to right, notice that this is going down, 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 down. All right. So as we go from left to right, it's going down. Therefore, this is negative. Is there an outlier? Is there a point that's really, really far away from all the other points? Yes, there is. All right. This point right here is far away from all the other points. So is there an outlier? Yes, there is. For some reason, this apartment is really, really expensive, while the other ones that same distance away are cheaper. Is there a cluster of points? Now, got into an argument in some of my other classes today. I'm going to say no. All right. Could you make an argument maybe for these that there's a cluster? You might be able to make an argument there, but when you take a look at the whole scatter plot, they're pretty much all equally spaced. So I'm going to say no, there's not a cluster. Somebody in my last class said, well, don't these 2 points make a cluster? No, 2 points do not make a cluster. You need like 3 or 4 or 5 points to make a cluster. All right, so 2 points don't make a cluster. Make an estimate with a distance of 1.6. If I go over to where 1.6 is, where do you think that next dot for 1.6 would be? Well, I would say that it would be somewhere right in here somewhere. All right. So what is that really at? You might say, I would say probably the best answer would be something like 550. Could you say 500 and be correct? Sure. Could you say 600 and be correct? Sure. Anything in that 500 to 600 range would be fine. All right. Take a look at the next one. The next one, we're looking at the number of polar bears and the ocean temperature. Now, obviously, this has to be in degrees Celsius because you're not going to have 1 degree water or 2 degree water because it would be frozen. It would be ice. So we're talking about degrees Celsius. So what is the relationship? As we go from left to right, what is happening to the graph? Is it going up? Is it going down? Is there no pattern at all?
It's going down.
It's going down. All right. As we go from left to right, the number of polar bears are going down. All right. So this would be negative because as we go from left to right, it is going down. Are there any outliers? Are there any points that are far, far, far away from all the other ones? I'm going to say no. Now, somebody in my last class said, well, look at this point. Isn't that point far away? It's not that far away. All right. An outlier is more like if there was a point down in here. All right. That's an outlier. Or if there's a point like way up in here, that's an outlier. This one is close enough to all the other ones that it wouldn't be an outlier. Is there a cluster of points? No, there's not. If you take a look at all these points, they're all pretty much equally spaced. So there's not a cluster there. Now, sometimes instead of having you do an estimate, sometimes what they're going to have you do is write a conclusion sentence. So they want to know, what is the graph doing? Well, as we go from left to right, just like we read a graph, notice that our ocean temperature is, as we go to the right here, notice that our ocean temperature is increasing. So as the ocean temperature increases, because we're going from left to right, so as the ocean temperature goes up or increases, what is happening to the number of polar bears? So as we go to the right on our graph, what is happening to the number of polar bears? Well, the number of polar bears are going down. So the number of polar bears is decreasing. So as the ocean temperature increases, the number of polar bears decrease because our graph is going down. All right, I want you to think about this one on your own. All right. You don't have to answer them out loud. Just think about these five questions, and then we're going to go over it. I'm going to give you about 1 minute. Take a look at these. Think about what you think. So when we take a look at this one, we're taking a look at the number of chapters and the number of typos. A typo is just like a mistake, right? The number of mistakes that were found in it. So what is the association? Well, as we go from left to right, we're going up, 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 up. So what is happening there? This is a positive association because it is going up. Are there any outliers? Are there any points that are far away from all the other ones? Nope. Are there any clusters? Are there any points that are really, really, really close to each other? Nope. If the book had 10 chapters, how many typos would you think there would be? So if we go over to 10 and we go up from 10, where do you think it would be? I think either 13 or 14 would be the correct answer. All right, that would be the best answer. Could you have 12? Yeah, you could. All right, but I think 13 or 14 would probably be the best answer. Write your conclusion. Well, as the number of chapters increase, so as we go over to the right and the chapters increase, what happens to the number of typos? The typos also increase. So as the chapters increase, the typos also increase. So